Our next problem, we have y squared plus 3y minus 9 equals to 0. So again, this is of the form ay squared plus by plus c equals to 0. So the values for a, b, and c are as follows. For our a, this is the numerical coefficient of our first term, and since there is no numerical coefficient here, it is understood as 1. So our a is positive 1. Our b is the numerical coefficient of our second term, and that is positive 3. And our c is our constant. This is negative 9. And then to determine the nature of the roots, we need to compute the discriminant, or b squared minus 4ac. So substituting the values, our discriminant here will be equal to, our b is positive 3, and raise this to the power of 2 minus 4 multiplied by a, which is positive 1, multiplied by c, which is negative 9. So this is 3 raised to the power of 2, that is positive 9. Negative 4 multiplied by 1, negative 4. Negative 4 multiplied by negative 9, that is positive 36. So our b squared minus 4ac here, this is equal to positive 45. So our b squared minus 4ac, or our discriminant here, this is greater than 0. Okay, let's change the color. Again, our discriminant here, since it is positive 45, it is greater than 0 and not a perfect square. Greater than 0 and not a perfect square. Okay, so the nature of the roots now, since it is greater than 0 and not a perfect square, our roots are real, irrational, and the roots are unequal. So again, our discriminant is greater than 0 but not a perfect square. So therefore, the nature of the roots are real, irrational, and unequal. These are our final answers. Our next problem, we have 2m squared minus 8m equals to negative 8. Okay, this is the quadratic equation that we first need to make this into the form ax squared plus by plus c. So again, we first need to make this of the form a m squared plus bm plus c equals to 0. So what we need to do is that we need to transpose negative 8 to the right side. So since this is on the right side, we need to combine all the terms on the left side. So we need to transpose this on the left. Transposing, we will now have 2m squared minus 8m. If we transpose negative, this will change sign. This will become positive 8 equals to, what will be left here is 0. Okay, so we are now of the form am squared plus bm plus c equals to 0. We can now find the values of a, b, and c. So the value for a here, this is the numerical coefficient of our first term. This is positive 2. And the value for b, this is the numerical coefficient of our second term. That is negative 8. And our c, which is the constant, that is positive 8. So to determine the nature of the roots of the quadratic equation, let us now find the value of the discriminant, or b squared minus 4ac. Again, this is the discriminant, b squared minus 4ac. So we are now going to substitute the values. So our b is negative 8. Raise this to the power of 2 minus 4 multiplied by a, which is positive 2, and multiplied by c, which is positive 8. So negative 8 raised to the power of 2, that is 64. And we have 4 times 2, that is 8, times 8, that is 64. So this will be negative 64. So our discriminant here is equal to 0. Okay. So we can now determine the value of the roots, or the nature of the roots rather. So again, our b squared minus 4ac is equal to 0. Okay. So this is equal to 0. Okay. Now, since our discriminant is equal to 0, the nature of the roots now, they are real, rational, and the roots are equal. So again, our discriminant is equal to 0. So therefore, the roots are real, rational, and equal. These are our final answers. Our next problem, we have 6m squared plus 11m equals to negative 4. We first need to convert this into the form ax, or rather am squared plus bm plus c. So what we need to do is we need to transpose negative 4 to the other side, so that all the terms will be combined. Okay, so transposing, we will have 6m squared plus 11m. If we transpose negative, this will change sign. This will become positive 4 equals to 0. So this is now of the form am squared plus bm plus c equals to 0. We can now get the values of a, b, and c. So our a here will be the numerical coefficient of our first term, and this is positive 6. Our b is the numerical coefficient of our second term. This is positive 11. And our c is our constant, or the third term, that is positive 4. And then let us solve for the discriminant. So the equation of the discriminant is b squared minus 4ac. So our discriminant here, this will be, our b is positive 11 raised to the power of 2 minus 4 multiplied by a, which is positive 6, and our c is positive 4. So we have here 11 raised to the power of 2, that will give us positive 121 minus 4 multiplied by 6 multiplied by 4. This will give us positive 96. So our b squared minus 4ac, this will be equal to 121 minus 96. This is positive 25. Okay. So our b squared here, or our discriminant now, b squared minus 4ac. So this will be it is greater than 0 and a perfect square. So this is greater than 0 and a perfect square. Okay, so the nature of the roots now, the roots are real, rational, and the roots are unequal. So again, our discriminant b squared minus 4ac is greater than 0 and a perfect square. So therefore, the nature of the roots are real, rational, and unequal. These are our final answers. Our next problem, we have 3n squared minus 12n equals to negative 7. So we need to make this quadratic equation of the form ax squared, or rather an squared plus bn plus c. What we need to do is that we need to transpose negative 7 to the other side so that all the terms will be combined. So transposing, this will now be 3n squared minus 12n. If we transpose negative 7, this will change sign. This will become positive 7 equals to 0. This is now of the form an squared plus bn plus c equals to 0. We can now get the values of a, b, and c. So our value for a here, this is the numerical coefficient of our first term. This is positive 3. Our value for b, this is the numerical coefficient of our second term. This is negative 12. And our value for c, this is our constant or the third term. This is positive 7. And then we will compute for our discriminant. So the equation of our discriminant is b squared minus 4ac. So let us now substitute the values of a, b, and c. So our b here is negative 12 raised to the power of 2 minus 4 multiplied by a, which is 3, multiplied by c, which is 7. Okay, so 12 here, 12 raised to the power of 2 is 144. So 144 minus 4 multiplied by 3 multiplied by 7, this is 84. And then 144 minus 84, this is equivalent to positive 60. Okay, now our discriminant here, or b squared minus 4ac, it is greater than 0. So it is greater than 0, and it is not a perfect square. So greater than 0 and not a perfect square. So therefore, the nature of the roots here, since our discriminant is greater than 0 and not a perfect square, the nature of the roots are real, irrational, and the roots are unequal. So therefore, real, irrational, and unequal are our final answers. Our next problem, we have m squared minus 12m plus 11 equals to 0. This is of the form am squared plus bm plus c. Okay, So again, this is of the form am squared plus bm plus c equals to 0. We can now get the values of a, b, and c. So our a here, this is the numerical coefficient of our first term. Since there is none, this is understood as 1. So our a is positive 1. Our b is the numerical coefficient of our second term, and this is negative 12. Our c is the constant or the third term, this is positive 11. And then we will now get the equation, or we will now get the discriminant. Our discriminant is b squared minus 4ac. Okay. Substitute the values of a, b, and c. So our b is negative 12, and raise this to positive 2 minus 4 multiplied by a, which is 1, and c, which is 11. So we have here 12 raised to the power of 2. This will give us positive 144. And we have negative 4 multiplied by 1 multiplied by 11. This will give us minus 44. So this will be positive 100. Okay. So 100 is a perfect square. So we will have here our discriminant b squared minus 4ac. This is greater than 0. And since 100 is a perfect square, so greater than 0 and a perfect square. So since our discriminant is greater than 0 and a perfect square, the nature of the roots now, they are real. They are real, rational, and unequal. So again, our roots are real, rational, and unequal. And these are our final answers.